Hello everyone, so welcome to my YouTube channel. So guys, today we are going to continue with the thermodynamics. Okay, so if you want to get the video for the thermodynamics, don't go for the video, just go to my channel, and in my channel go to the playlist. In the playlist you will get the playlist of thermodynamics, so you will click there, then you will get the like video 1, video 2, video 3 there, so you can study from there in place of going and searching in videos. Just go to my channel, go to the playlist, and you will get there. Ashte. Okay, so in today's video we are going to write about the reversible process and irreversible process. Okay, so first I am going to give the heading about the reversible process. Okay, now see, reversible process, whenever we talk about the reversible process, the reversible process means we can go forward and the same we can come backward. Are oh pyare, what happened here? Same we can come backward. So forward, backward. So that is reversible process. So reversible process will happen in, like whenever the reversible process will happen, we can say it is in equilibrium. It is in equilibrium. Okay, so equilibrium process is the same. Forward reaction equals to backward reaction. So reversible process will happen in equilibrium. Another one is the irreversible process. Okay, irreversible process. Irreversible process. Irreversible process means once you will go, that's it, you cannot able to come back. Okay, that is irreversible process, you can just move on. So irreversible process is not the equilibrium. Okay, so we will write here reversible reversible process. So here we will talk about the reversible process, irreversible process, both like this. For this condition, guys, suppose this is a cylinder, this is a cylinder and this is the piston. Okay, this is the piston. Okay, now what is happening? This is the internal force, sorry, internal pressure. This is the internal pressure acting on the this piston, and this is the external pressure acting upon the system. So internal pressure, external pressure, when they both are in equal, it's called equilibrium. Okay, so here we will talk about first thing is reversible process. So whenever we want to check the reversible or irreversible process, what we have to do, we will see reversible, irreversible process. So what we will do, we will take the heat, we will give the heat to the system. What we will do, we will give the heat to the system. Okay, we will give heat to the system. When we will give heat to the system, I have discussed before, when we will give heat to the system, what will happen? The temperature of the system will increase. When the temperature of the system will increase, then that time kinetic energy of the molecules will increase. So kinetic energy will increase means the collision will increase, and then what will happen? It will start hitting randomly everywhere, to the particles, to the wall, to the piston, and then what will happen? The internal pressure will apply the force over the piston, and then the piston will move up. So what will happen? Little external force applied, the piston move up. So what will happen? Small step, small. It's not like suddenly the high external pressure will apply. No. Sorry. Suddenly the high internal pressure will apply. No. The internal pressure it will apply is very less. So that how much it will apply the internal pressure, that much it piston will go up. So what will happen? It will go step by step, and the step is very small step. It's not like a sudden change. It will be this like small internal pressure, small piston will move. Again what will happen? After moving, they both will come again in the equilibrium. Okay, so again the internal pressure will move, again the piston will move up, again the internal pressure will move, again the piston will move up, and every time what will happen? As this process will happen, they will come under the equilibrium. As the process happening, they will come under the equilibrium. So after every small step, they will reach in the equilibrium. After every small step happen, again the internal pressure and external pressure will become equal. Again what will happen? Again we will give the heat. Again the temperature will increase, and again kinetic energy will increase. Again what will happen? The internal pressure will increase. So internal pressure will increase, so piston will move up, and then again what will happen? When the internal pressure equals to external pressure, the piston will stop there. So again they will attain the equilibrium. Again heat we will produce. Again we will give the heat. Again temperature increases. Again kinetic energy increases. So what will happen? Again the internal pressure will move. Again the piston will move. Again the internal pressure equals to external pressure. They will reach the equilibrium. So again like this process. So slowly in the reversible. Irreversible, they will not attain the equilibrium. Okay, irreversible means we will move it fast. We will remove the external pressure fast and it will go up like this. That is irreversible. That is irreversible. Okay. So what will happen here? Reversible process we will write. It occurs. Handwriting Babu bhaiya lo. Don't worry about the handwriting. It occurs in infinitely. It occurs in infinitely. It occurs in infinitely small steps. As I have said, they will go little up. So it occurs in infinitely small step. Same irreversible also. If we talk about the irreversible also, reversible means it occurs in infinitely small steps. Small steps. Because suddenly we will not apply the heat. We will apply the heat slowly. So temperature will increase slowly. Kinetic energy will increase slowly. So internal pressure will increase slowly. So when it will increase slowly, what will happen? Piston will move up. Then the external pressure, what will happen? External pressure will be less. So again it will move up. After moving like small changes, after a small movement, again the internal pressure equals to external pressure, they will reach the equilibrium. Again like this will happen. So after every small change, what will happen? The internal pressure equals to external pressure. Why? Because this is reversible process. After every step they should have to gain a equilibrium position. After every step they should have to gain a equilibrium process. So that's why it occurs in infinitely small steps. But here this is not possible. Here in irreversible, what will happen? The internal pressure will not move small, it will move like a very fast. Okay. Irreversible process we will write here. Irreversible process will write here. It occurs in finite steps. It occurs in finite steps. Means 3 or 4 steps, what will happen? It will reach, the internal pressure will go very fast. Okay. And the internal pressure will be more as compared to the external pressure. So it occurs in finite step. Next we will write here the second point for the reversible processes. At any step, the system and the surrounding, at any step, the system and the surroundings. This note you have to write. This is very important. Write on the notes with me. This at any step the system and the surroundings can return to their original state. So to their original state, what does this mean? To the original state means, just now I explained, after every, what will happen? After every increase in the internal pressure, what will happen? Again the internal pressure and external pressure will reach to the equilibrium stage. Again there is an increase in the internal pressure. Again the piston will move up. Again after that internal pressure and external pressure will come under the equilibrium. So at any step the system and surrounding can return to their original state, because this is a reversible process and they will attain the equilibrium at each step. Okay, now here what we will write? We will write at any step, the system, at any step the system and the surroundings, at any step the system and the surroundings the system and the surroundings cannot return cannot return to their original state, cannot return to their original state, cannot return to their original state. Understand? अरे और प्यारे बोलो रे भैया. Yes. Now what will happen here? System is in equilibrium. System is in equilibrium at every step. System is in equilibrium at every step. As I have said, after every step it will be in equilibrium. So what will happen here? Here we will write system is in equilibrium. System is in equilibrium only at initial and final state. Only at initial and final state. So here what will happen? Only at the starting they will be in equilibrium, and then suddenly the internal pressure will increase, and at final stage they will be at equilibrium. Okay, final step it will stop. Okay, so see, here the system is equilibrium at every step. After every increment the internal external pressure will become equal, but here the system is in equilibrium only at initial and final state. So here we will write, see, equilibrium, this type, like, you know, it is means reversible process. It is imaginary. Reversible process is what? Imaginary. Very difficult, guys, very difficult to get the reversible process. The reversible process is imaginary and cannot be achieved in real. Okay, so what is happening? It is imaginary. This reversible process, what I am saying, that it will increase, it is imaginary and cannot be achieved in real. But when we talk about irreversible, we will write it actually occur in nature. Okay, okay. So this is the difference between the reversible and irreversible process. Are oh pyari, understand? Yes sir. If you are watching this video, if you are understanding, then just please hit the like button, so I will get to know yes you understand. Now guys, next thing we will start with the reversible expansion. See here the two things is there, expansion and compression, right? Reversible expansion and compression. So if you understand the expansion, compression will become very easy. Okay, so see, expansion means what will happen. Understand, very important thing. Expansion means we are taking the heat. So as the, see, expansion, if I will tell that expansion means what will happen. The piston, suppose this is a piston is moving up, right? Piston is moving up, so that's why it is expanding. Okay, suppose this is the lower level, this is the piston here. So piston is moving up, this is only the expansion. So when the piston will move up, when the internal pressure is more as compared to external pressure, then only the piston will move. So moving up means expanding. So if it is expansion is happening, what will happen to the volume? There is an increase in the volume. Okay, there is increase in the volume. So guys, how the expansion will happen? Expansion will happen means when we will take the heat, when the system will absorb the heat, right? When the system will absorb the heat, what will happen? The temperature of the system will increase, kinetic energy will increase, the collision will increase, and then the internal pressure will increase. The internal pressure will increase means it is expanding. The expansion is happening, increase in the volume. Okay, and during the expansion, what will happen? Work done is on the system. Work done is by the system, right? It is expansion means work done is by the system. Work done is not on the system. Heat is taking, heat is observing, the system is absorbing the heat. So Q is positive, Q is positive. But what will happen to the W? Here what is happening? Expansion means, yes, expansion means what? Work is done by the system. Expansion means work is done by the system. It is expanding. So that's why W is negative and Q will be positive. Okay. So what will happen in reversible expansion? I will write it here. So in reversible expansion, I see reversible. First of all, condition what we know, reversible means equal. At every, after every step they will attain the equilibrium, right? After every step they will attain the equilibrium. So if they are attaining the equilibrium means internal pressure is equals to external pressure. So we will write here in reversible expansion what will happen? External pressure is almost equal to internal pressure. External pressure is almost equal to internal pressure. External pressure is almost equal to internal. Guys, I am not saying that external pressure is equal to internal pressure. I am saying external pressure is almost equal. Why I am saying almost equal? Because every time the internal pressure will hit, the piston is going up, again they are reaching the equilibrium. Means external pressure is little less as compared to internal pressure, but it is a reversible process now. It is a reversible process. So after every process the external pressure is equals to internal pressure. Okay, we know that external pressure is little less, so that's why it is expansion is happening. It is expansion is happening. It is expanding. The piston is going up, it is expanding. So external pressure is little less as compared to internal pressure, but it is a reversible expansion. So after every step they will reach the equilibrium. So that's why I will say external pressure is almost equal to internal pressure. Okay. So here now pressure is done. Now when we internal pressure is applying, what is happening? Work done. Work done is by the system, right? Work done is by the system. So here we will get to know in reversible process what we get to know, external pressure is almost equal to internal pressure. So what we will say, guys, see, work done. We'll talk about work done is understand work done. This is reversible process. So work done is reversible. Work done, work done in. Work done. Okay, work done in reversible expansion of what? Gas, right? Yes, sir. Work done in reversible expansion of gas. Okay, so here what we will do, guys, work done in reversible expansion of gas, what we will do here, understand, if when we have to find the work done, when we are finding the work done in reversible expansion of gas, so what we will do here, understand here, very important thing, guys, external pressure is replaced by internal pressure. So that's why we know external pressure is almost equal to internal pressure. But when we talk about work done in reversible expansion, so work done in reversible expansion, the expansion is what is happening, internal pressure is applying, internal pressure is acting, right? Internal, there is a no work of external pressure. What is happening? Internal pressure is applying, so there is no work of external pressure, and external pressure is less as compared to internal pressure, but it is a reversible, so we'll say that external pressure is almost equal. But when we will do the work done in reversible expansion of gas, the external pressure we will not use, we will use the internal pressure. The external pressure is replaced by internal. Because of the internal pressure only work done is happening in expansion. Okay, so that's why external pressure is replaced by internal pressure. So guys, we know for ideal gas what is the pressure? nRT by V. Right, ideal gas formula is what? PV equals nRT. This is V. PV equals nRT. So P is equals to nRT by V. Okay, so here pressure is directly proportional to the temperature. Okay, fine. So work done is in reversible expansion of gas, the external pressure is replaced by internal pressure. Okay, So what we will write here, we will write like same in reversible expansion, the external process, sorry, the external pressure here, the external pressure decreases. Okay, in like reversible expansion, the external pressure decreases. How it will decrease? By a small amount, right? The external pressure decreases by a small amount continuously, right? Because as what is happening, as the internal pressure is going up, heating up, what is happening? The external pressure is decreasing small, but again they are reaching to the equilibrium, but still the external pressure is decreasing. So that's why we will replace the external pressure with internal pressure, because main work is done by the internal pressure for the expansion. The external pressure decreases by a small amount continuously, so as to remain so as to remain so as to remain infinitely small. Okay, infinite, sorry, spelling गलत लिख दिया. See, infinitesimally means infinitely small. It is increasing. The external pressure is decreasing. Continuously it is decreasing the external pressure. So that's why internal pressure is increasing continuously. So that's why it is expanding continuously. But it is very infinite small, very infinite. So that's why we are using here almost the external pressure is almost equal to internal, because decrease is very small. So that's why what we will see here, the external pressure decreases by a small amount continuously, so as to remain infinitely smaller than the, so what is happening? Smaller than the internal pressure, and gas expands. Okay. So here internal pressure is more and external pressure is decreasing slowly, and internal pressure is increasing slowly. So what is happening? So that's why gas expands. Okay. Now here one word, guys, you have to understand this word: quasi-static process. So quasi-static process, what we will say, you can write here, quasi-static process means it is an infinitely slow process. Quasi-static process means infinitely slow process. Infinitely slow process means which, where the infinitely slow process is happening. अरे बोलो रे प्यारे, अरे जल्दी रे, where the infinitely slow process is happening? Yes, on the external pressure. On the external pressure, the infinitely slow process is happening, right? Infinitely slowly the external pressure is decreasing. So external pressure is decreasing means piston is going up slowly. So that's why internal pressure is increasing slowly and the gas is expanding slowly. So that's why it's called a expansion. Work done is by the system. Internal pressure is greater as compared to external pressure. So that's why we will use here the internal pressure in the work done. And what is happening in the expansion? The volume is expanding, means increase in the volume. Okay. Yes, sir. Now here, guys, if I want to write in this, like, work form, so I will say that work, how the work is done, guys. Work is not done suddenly because it is reversible. Irreversible means work is happening fast, okay, but reversible means work is happening slowly means what I will write? Small. Okay, so small means I will write the differential form of work. Differentiation means what, guys? Breakdown. So here also differential form of work means breakdown. The work happen in the breakdown, small, infinitely small process, quasi static process it's happening. Okay, because every step, after every step they will attain the equilibrium. After every step, what is happening? They are attending the equilibrium. So that's a quasi static process. So differential form of work, we are going to write the formula. Okay, so till here I hope you understand, guys. These all are the notes what you have to write. I know the handwriting is very good. Don't get upset like, oh sir, your handwriting is very good, our handwriting is very bad. It happens, guys. When you will reach to my level, your handwriting will also become this good. Okay, so now guys we have to write the differential form of work. Okay, now very important thing, differential form means small. As we know, the work is happening small, the piston is moving up very small, external pressure is decreasing very small, internal pressure is increasing very small, so expansion is also happening very small. So small means what I'm going to write, I will write dw. Small means what, dw. And this is a differential form of work, it's not the total work done. Total work done is denoted by w. Okay, and differential form means small, so that's why dw, because d indicates the differential, right, differentiation, and this is the integration, this is the differentiation, right, and this is the integration, so that's why, yeah. So guys, now what is happening, differential form of work means very important thing, which type of force is applying, internal pressure, right, internal pressure. So I will write down the pressure, and whenever I will write down the pressure, guys, it is the internal pressure, internal pressure. Okay, so internal pressure is happening. So what is happening, as the internal pressure is happening slowly, so what is happening, the expansion. The expansion means what is happening, guys, change in volume. Change in volume means delta V. In chemistry we know, guys, if the word delta will come, see, this is a triangle for the mathematics, but for chemistry we will say, pronounce it as a delta. In chemistry we will say it as a delta. So whenever we use the delta, delta indicates that there is a some change, there is a some change. So delta V means change in volume. Before the volume is this, after expansion volume increase. Okay, initial and final volume will get change, obviously, before and after the expansion happening. So delta V. Okay, so delta V means, guys, how we will find the final volume minus initial volume. And what is happening, work, expansion means work is done by the system, right, work is done by the system to the surrounding. So when work is done by the system to the surrounding, it will be minus. So you can write minus pressure final volume minus initial volume. Okay, this is for the, guys, expansion. This is for the expansion. So this is for the expansion. Same if you want to write for compression. This is what, guys, this is for the expansion. This is for the expansion. Okay, one thing, एक thing ले लेते guys, one thing. चलो ठीक है. If I am using small d here, तो I will use the small d. Okay, normal के लिए. Small d, I am using the small d here, so I will use the small change in volume. Guys, there are two. This is also a delta. 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 So this delta is also means change. This delta is also mean change. But if I will use this delta, means there is a small change. There is a small change. Obviously, we know in equilibrium what will happen. The piston will move small. The change is small. Okay, so small work done is happening. So that's why what is happening? Small change in the volume, small change in the volume, and this delta indicates the big change. This delta indicates the big change. Okay, so expansion, what will happen, guys? This expansion means what? It is expanding. It is expanding. So work is done by the system to the surrounding. Work is done by the system. So that's why it is minus P internal Vf minus Vi. Okay, if the same you want to write for compression, the same thing if you want to write for compression means what will happen, guys? Compression means this negative will become positive. This negative will become positive. Okay, this negative will become positive. So what will happen? See here, this in expansion what will happen, देखो, in expansion में suppose it start from here, to initial volume, and if suppose it stopped here, to final volume. The expansion, what we know, final volume is greater than initial volume. Final volume is greater than initial volume. Why? Because it is expanding, right? It is expanding. So same if I will take for the compression. Compression means what, guys? Compression means the pressure. Okay, compression means here we will use the external pressure. Compression means external pressure. Why? Because external pressure is more, so that's why it is compressing. External pressure is more, so that's why it is compressing. So I will write down the external pressure. And very important things here, guys, work is done on the system, because now we have to do compression, we have to compress. So work is done on the system. The work is done on the system means this will become plus. This will become plus. And now what? dV means Vf minus Vi. Okay, dV means Vf minus Vi. dV means, guys, same, guys. See, compression also what is happening? Change in the volume. From here it will reach here. So change in the volume, right? So dV. But here what will happen, guys? Here in compression, suppose starting it is here, so initial volume, but after that it reached down to final volume. So in compression what will happen? Initial volume is greater than final volume. In compression, initial volume is greater than final volume, because initial volume is up, we are compressing, so after compressing the volume will decrease. So initial volume is more than final volume. So this is the formula for the differential form of work for both expansion and compression. I hope you understand this. Yes sir. Okay, ठीक है, हो गया, ठीक है. Now guys, we will write down the work done. This is very important. Now we have to write down the work done formula. Okay, चलो ठीक है, we are going to write down the work done formula. Okay, work done in different process. We will see work done in different रिवर्सिबल, बिकॉज इरिवर्सिबल तो भैया नहीं देखना अभी. वर्क डन इन डिफरेंट रिवर्सिबल. रिवर्सिबल मीन्स व्हाट विल हैपन, गाइस? रिवर्सिबल एक्सपेंशन. बिकॉज इफ यू नो अबाउट द एक्सपेंशन यू कैन राइट फॉर द कंप्रेशन, राइट, लाइक दिस. व्हाट इज चेंजिंग? द साइन इज चेंजिंग, माइनस टू plus, and everything will remain same. Expansion, final volume is greater than initial volume. Compression, initial volume is greater than final volume. That's it. So work done in different reversible expansion of gas. Okay, now we are going to see work done in different reversible expansion of gas. Different process. Okay, the first process we are going to take is reversible isobaric process. Reversible isobaric process. Reversible isobaric expansion I will write, because everywhere what we are seeing the expansion, because this is expansion. So reversible isobaric expansion. So guys, isobaric expansion, isobaric means bar. Iso means, guys, what? Iso means we know same. Iso means same, or you can say constant. Iso means same, or you can say constant. So bar means when we will use the bar. Hey bhaiya, or oh pyare, bar means don't understand that bar. Sir, bar. Not that bar. Okay. So isobar, bar means whose unit is bar? Pressure. So isobar means constant pressure. Isobar means constant pressure. Constant pressure. Which pressure will? Constant pressure means what, guys? Always zero. Right, constant pressure means what? Always zero. Every time the pressure will remain same, no change in the pressure. So constant, zero. To understand why, guys, we have a two type of pressure: internal pressure, external pressure. So in expansion, whose pressure is very less? External pressure, because it is expanding. The external pressure is less, so that's why internal pressure is expanding, right? So that's why in reversible isobaric process, external pressure is constant. External pressure is constant means external pressure is almost zero. External pressure is almost zero. तो देखो भैया रे ओ प्यारे, see here, यहाँ देखो रे. तो reversible isobaric process, if I want to write the reversible isobaric expansion, reversible isobaric for expansion. For expansion means external pressure is zero. External pressure is zero. So see the formula. Right, expansion means we are not taking the internal pressure, we are taking the, we are not taking the external pressure, we are taking the internal pressure. So whatever, let the external pressure be zero, who cares? The work done, what will happen? Total work done, total, guys, I will write the W means total work done. If I will write the W means it will be total work done. Total work done. And guys, it is very common, expansion means work done by the system, compression means work done on the system. Okay, the expansion means work done by the system means it will be minus, and external pressure is zero. Okay, because it is expansion, the external pressure I will take zero, because it is isobaric. So which pressure we will take? The constant. Which pressure will become zero? External pressure, because internal pressure is increasing, so that's why it is expanding. So I will take the P. Now it is total work done. Total work done means big. So that's why I will take delta V. The formula will remain same guys, this dV or delta V, it will same, final minus initial for the expansion. Okay, for the expansion guys we will take the internal pressure. So expansion में निकलेगा बाबू भैया लोग, expansion means work done is this. If suppose same I will write reversible isobaric compression, I will write reversible isobaric compression. So in this condition what will happen guys, reversible compression. So compression means what will happen, that time we will take the, what we will take, yes, that time internal pressure will be zero. See, don't think that that time external pressure will be zero. No, 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 no. For expansion I am taking external pressure is zero, so that's why internal pressure is acting and it expanding. If I will take the reversible isobaric compression, compression means external pressure is acting, so internal pressure will become zero, internal pressure will become zero, and external pressure formula is this only, W equals plus P external delta V. Okay, that's it, and the condition will remain same. Understand, every time the condition will remain same for the expansion, Vf minus Vi, compression, sorry, expansion में final volume is greater than initial volume, compression guys initial volume is greater than final volume, because compression it is compressed, the final volume will be less. So this condition will remain same whether it is expansion, every time final volume is greater than initial volume, compression guys initial volume is greater than final volume. Okay, so this is for the expansion. Expansion means external is not working, it is zero. Compression means internal is not working, internal is zero, because compression when it will happen, when the external pressure is zero, internal, sorry, when external pressure is acting, internal pressure will be zero. So this is for the reversible isobaric process, means isobaric expansion. Now guys next we will write, अरे भैया क्या हो गया, next the second number we will write, चलो second number reversible, again reversible isochoric. Guys, there are lots of things you can say, isochoric, isochoric. Okay, so reversible isochoric expansion, reversible isochoric expansion. Now guys, again iso means same or constant, we will take its value as a 0. So iso means same, choric means what guys, choric we will use for volume, choric means we'll use for volume. Here volume is constant or volume is same. So see, baric means bar means pressure, so here pressure will be 0, or pressure is constant or pressure is same. Here isochoric means choric will come for volume, so here volume is same, volume is constant or volume equals to 0, you can say anything. Now one more thing is isothermal. Thermal means what, temperature. So temperature is constant, temperature is same, or temperature is 0. So these three things you have to understand. Okay, so isochoric means what will happen, volume is constant. Now guys understand here, if now I'm writing here isochoric expansion for the expansion process, So for the expansion process what we can see, dW, this volume is 0 guys, volume is 0, what will happen, dW is 0, right? Volume is 0 means dW is 0, right? Then joldi bolo bhaiya, joldi the focus here. If volume is 0, this will delta V is also 0, so small w dW is also 0, W is also 0, right? So volume is 0 means what is happening, delta V is 0, so bhaiya 0, khatam, khalas bhaiya, khalas. Okay, now next we will take next we will take next third number is reversible isothermal expansion. The isothermal expansion, as I have told you, what temperature is constant, temperature is same, or temperature is 0, isothermal reversible expansion. So see here guys, very important thing. Now you can see here isobaric, so we have a pressure over here, so that's why we'll take the external pressure 0, internal pressure into delta V. Okay, here guys isochoric means delta V is 0, so we have a delta V, so this is 0 means W is 0. But when we talk about isothermal means temperature is zero or temperature is constant or temperature is same. Bhaiya, are oh pyare, in dw this formula we don't have the temperature only, we have pressure and we have volume. So when the pressure will come, we will make the external pressure zero for the expansion and internal pressure zero for the compression. So that's why formula will remain same, minus P delta V. Okay, for the work done. For the isochoric process means volume is zero. Either you are doing reversible or irreversible. Whatever happening, expansion, compression. Volume is zero means work done is zero. But here guys, we don't have this. We don't have temperature only in the expression. So what will happen? Here the log will come. And the final expression we are going to write is, again expansion means work done by the system. Minus 2 point, just understand the final, no need of derivation and all, they were not asking the examination. Minus 2.303 nRT. N is the number of mole, R is the universal gas constant, T is the temperature. If they will give, it's okay, otherwise we'll use the room temperature, that is 298 Kelvin standard temperature. Okay, log of final volume divided by initial volume. Here this is the formula pyare for the reversible isothermal expansion. Understand the formula. Okay, now guys, done. Expansion, reversible expansion is done. Now we will go for irreversible. Okay, this is done for the reversible. Now we will move on for irreversible. The first what we will see, see irreversible. We have two things. First thing is, for irreversible we have two things guys. First is irreversible isothermal and irreversible free expansion. We have only two things, isothermal and free expansion. ये भाई दो भाई. See irreversible guys, irreversible we don't have this. क्या बोलते हैं? This irreversible pressure, irreversible volume, no. Irreversible isothermal, irreversible isothermal expansion, irreversible isothermal expansion. Okay, irreversible isothermal expansion. So here what will happen guys, in irreversible means it is not in equilibrium, so what will happen here, irreversible means directly the internal pressure will increase, because what is happening, expansion. So here directly the internal pressure will increase, so external pressure is very less as compared to internal pressure, right? Here what will happen, directly we can say the internal pressure is very greater than external pressure. The internal pressure is very greater than external pressure. The external pressure is very small as compared to internal pressure. Okay, because it is irreversible, equilibrium will not attend here, so it is a finite small, directly it will go up. Okay, it will not go small, okay, it will go up very fast. So we'll write in irreversible isothermal expansion, what will happen, external pressure, okay, this external pressure is very less, external pressure is very less as compared, external pressure is very less as compared to internal pressure. Okay, external pressure is very less as compared to internal pressure. So that's why what will happen here, the change in the internal pressure is very high. So that's why we cannot able to determine the internal pressure here. So work done, what we are going to take, work done for irreversible, is, so work done, expansion means work done what, by the system, work done by the system. So it will be minus, and internal pressure is very big, very large change is happening. So we will take here the, internal pressure is very large guys, internal pressure change is very large. So that's why we cannot able to consider the internal pressure, we will consider the external pressure, because external pressure value is very small and is it easily to measure. The external pressure into what, expansion means what, change in volume, so delta V. Okay, So we get to know, like in any irreversible process, we always what we see that external pressure is very less as compared to internal pressure. Okay, so that's why what will happen here, internal pressure is very large as compared to external pressure, so that's why internal pressure value will change very drastically. So that's why we will take the external pressure, because external pressure value will change very less and it is easy to consider. Okay, so that's why external pressure which is very less as compared to internal pressure. So while calculating the work done by the gas in irreversible isothermal expansion, we will use the external pressure, we will not use the internal pressure value. So that's why what will happen here. Okay, so that's why we will take this work done in irreversible isothermal expansion means minus, because work done is by the system, minus, and this is what external pressure, we will consider the external pressure into delta V. This is the thing, that's it. Now next thing guys, we will take irreversible free expansion. So these all the notes you have to write, guys. What I'm writing here also you have to write. Here I have also written, you have to write. Okay, now next is what? Next is irreversible free expansion, guys. Whenever we tell about free expansion means no matter is there to stop them, nothing is there. Nothing means no matter, either no solid, no liquid, no gas, nothing is there. So what we will say, it's free expansion means we will say that, what we will say, no matter is there, so that's why it is a free expansion. So directly we will write here the free expansion, like if an ideal gas expands against vacuum. Okay, if an ideal gas expands against vacuum, because free expansion, you can expand freely means no matter, nothing is there to stop, it's a free vacuum. So if an ideal gas expands against free vacuum, the irreversible expansion is called free expansion. So what we get to know here, we get to know that it expands again vacuum, nothing is a free expansion, nothing is there, guys. You can expand freely, nothing is expanding here, nothing is stopping here, no matter is there to stop. So that's why ideal gas expand against vacuum. So vacuum means what? Free expansion, freely it will expand. Okay, so it will be every time it against vacuum. Okay, so what will happen, guys, when it will expand freely? So in irreversible, what we will take? We will take the external pressure, we will not take the internal pressure, we will take the external pressure. So what is happening, guys? Vacuum is there, vacuum means no external pressure is applying. So what will happen? External pressure equals to 0. Why external pressure equals to 0? Because it is against vacuum, it is not against pressure, it is against vacuum. Vacuum means nothing is there, the external pressure is 0. If external pressure is 0, what will happen to the work done, guys? So irreversible work done is also 0, right? Yes sir. Okay, now just see the graph. Arey oh pyare, graph is important re bhaiya. Okay, see here, this you will see the pressure versus volume graph. Pressure versus volume graph. So this is reversible, isothermal expansion. reversible isothermal expansion. So that's why isothermal expansion means temperature is constant. Temperature is constant means, so that's why we took the pressure versus volume graph. Pressure versus volume graph. So guys, see the graph is like this. It starts from here and it will go like this. Okay, like start from here. So start from here means P1 V1, then it will be here P2 V2. Means what we can see, here, see volume was here, now it reached to here. Volume was here, it reached to here. So what is happening? Expansion, increase in the volume, right? Okay. So reversible isothermal expansion. Okay, so this is the, like, how we will go. This is the arrow. See P1, from P1 V1 we will move like this, P2 V2. Okay, so volume is increasing, initial volume, final volume, so expansion. So this is, understand guys, this is the graph. This is the graph for what? Reversible isothermal expansion. This is the graph for expansion. So it will go like this. Arrow is like this for expansion. Okay. If it is guys irreversible तो भैया बहुत easy है. See irreversible, what will happen? This is reversible. So this is irreversible. This is irreversible isothermal expansion. Okay, this is irreversible isothermal expansion. So irreversible isothermal expansion means pressure and volume. Guys, irreversible, it is very easy. It will go just a straight line. Okay, actually irreversible they will not ask. Okay, irreversible भैया बहुत ये होता है. Irreversible leave it guys. Irreversible नहीं होता, ना ही पूछता भैया. Just you have to focus on the reversible. This irreversible का थोड़ा दिमाग खराब है. Who, no one cares about that irreversible. Okay. So work done. So what will happen here? Reversible isothermal. So P1 V1 it will go like this, P2 V2. Okay, V1 V2, initial volume, final volume. So that's why it is expansion. Volume is expanding, and the line will go like this. So guys, give the arrow like this. If you will give the ulta arrow, it will become moi moi. So that's why this is the correct diagram for reversible isothermal expansion. Okay. Now we will see the thing. कहाँ गया भाई? हाँ. See here guys. Free expansion. Free expansion means what will happen? Expansion of a gas in vacuum. So what will happen? External pressure is zero. It's called free expansion. So what will happen? No work is done during free expansion of an ideal gas, whether the process is reversible or irreversible. Process is reversible or irreversible, we don't care. It will be external pressure is zero, work done is zero. Okay. Now here guys, see, you can see here, we know this form W is equals to minus this, right? We know this formula W equals to minus, because work done by the what? Work done by the system. So W is equals to minus Px external delta V. So we know, see, this delta U formula is what we have studied at thermodynamics first law. Delta U is equals to Q plus W. So Q is what? Heat, we will take Q as Q only. Why? Because see, expansion and all will happen when, as I have said you starting of the class, when we will apply the heat. When a system is absorb the heat, then temperature increases, kinetic energy increases, expansion will happen. So heat is absorbed by the system. So that's why it is a plus Q. So that's why guys, see, plus Q, and W is what? This minus P external. Right? Minus YW, because heat is coming, expansion is happening, means work done by the system. Okay. So this is the, we will get delta U equals Q minus P external delta V. So now see here, if the process is carried out at constant volume means isochoric process. So delta V 0 means delta U is equals to QV. Okay, V means QV, like heat is supplied at constant volume. Okay, so that is the thing here. If suppose it is a pressure, external pressure 0, right? External pressure is 0 means this. Vacuum means external pressure is 0, work done is 0. Work done is 0 means again delta U is equals to Q, because W is equals to 0, this thing will become 0. Right here also you can see work done is what? Work done is 0 means delta U is equals to Q in free expansion. Okay. Now see this, isothermal and free expansion of an ideal gas. So isothermal means T is equals to constant. So what will happen? W0, we know, right? In a vacuum what will happen? W0, external pressure 0. Okay, so we know this formula, delta U is equals to Q plus W. Okay, now here guys, if temperature is constant, see for this condition, I am talking about this condition. If I will take isothermal and free expansion, see if you will take only free expansion means W is equals to 0, work done is 0, then delta U is equals to Q. Delta U is equals to Q only if I will take the free expansion. But here what we are taking, I am taking isothermal and free expansion. So isothermal means temperature is constant. Temperature is constant means temperature is not changing. So temperature is 0. Right, temperature is constant means temperature is not changing. Temperature is 0. If temperature will become 0 guys, heat is also 0. Heat will also become constant. So that's why if I will take isothermal, see free expansion means U is 0. Isothermal means temperature is constant means Q is also 0. Right, temperature is not increasing, heat is not increasing, Q is also 0. So that time isothermal and free expansion both we will apply, then delta U is also 0. Understand the condition. To understand the concept, no need of by hurting the things. Understand the concept. When if only free expansion, what will happen? If isothermal and free expansion both we will use, what will happen? If we will use the isocoric, what will happen? If we will use the isobaric, what will happen? Okay, so isobaric, see isocoric means again delta U is equals to Q, because coric means delta V is equals to 0. So this part will become 0, but again delta U is equals to Q. If same this formula is there guys, if same this formula is there and I will take the isobaric means pressure is 0, so this will become 0, again delta U is equals to Q. So every time either you will take the isocoric means volume constant, pressure constant, delta U is equals to Q in both the condition. But if you will take the isothermal, then delta U is equals to 0 because Q is equals to 0 in that process. Okay, so this is for isothermal irreversible. Okay, not a reversible, irreversible. So irreversible means what will happen guys? Irreversible means delta U is equals to 0 for irreversible. Okay, so isothermal, what will happen? Jaldi bolo bhaiya, jaldi. See isothermal means what will happen? Delta U is equals to 0. Just now I said isothermal means delta U is equals to 0. If delta U is 0, we know this formula, delta U is equals to Q plus W. If delta U is equals to 0, then Q equals to minus W. Q equals to minus W. Right, if delta U is equals to 0 for isothermal. Okay, I'm not talking about free expansion. Free expansion is done till here. Now guys, we are talking about just see isothermal irreversible. Just we are talking about isothermal irreversible and reversible, whatever. Free expansion is not here. So isothermal means what will happen? Isothermal means delta U is equals to 0. Delta U is equals to 0. If delta U is equals to 0, because understand one thing, isothermal means temperature is constant. We are not taking the heat. If we are not taking the heat, so Q is equals to 0 because temperature is constant, heat is constant. If we are not taking the heat, work done will not happen, expansion will not happen. Right. So what will happen? Here, understand one thing, उतना नहीं सोचना है भाई, simple thing. Here isothermal means delta U is equals to 0. Right, delta U is equals to 0. If I will apply the delta U is equals to 0 here, then Q is equals to minus W. So W is already this. W value is what? W value you can see guys is minus. So minus W. So minus will become plus. Minus will become plus. Same here for isothermal. Again isothermal. What? Delta U is equals to 0. Isothermal means delta U is equals to 0. How the delta U is equals to 0? As I have said you, Q plus W. If we are not taking the heat, if you are not taking the temperature, so heat will remain constant. If heat will remain constant means Q is equals to 0. If heat is constant means no work done is by the system. Work done will also become 0. Right? No work done. So delta U is equals to 0. So delta U is equals to 0 in isothermal process. So delta U is equals to 0 guys, what will happen? Delta U is equals to 0 means Q equals to minus W. So Q is equals to minus W. That all formula is become plus, because minus minus plus. And for adiabatic as we know, adiabatic Q is equals to 0. So delta U is equals to W for adiabatic. Okay, so these all formula guys we have written for isothermal reversible. See here, all the things we have written for reversible, right? We have written for reversible. We have written for reversible. All the formulas guys we have written for reversible process. देखो भैया, see reversible expansion. We have written the formula for reversible expansion, right? This all the formula we have written for reversible. Irreversible means, see this, irreversible means Q is equals to minus W. So minus W means already W value is in minus. Minus minus will become, all value will become plus. All value will become plus here. All value will become, see here, this plus plus plus. Okay. For adiabatic change Q is equals to 0. So भैया delta U is equals to W हो जाएगा. Understand this process? Yes. Now we will see this 5.2, 5.3, 5.4. 2 liter of an ideal gas. Okay, 2 liter of an ideal gas at a pressure 2 liter. Initial volume is T liter. 2 liter of an ideal gas at a pressure of 10 atm expand isothermally. Okay, isothermally, temperature is constant, into a vacuum bhai, until its volume is 10 liter. So initial volume, final volume they had given. Vacuum is what guys? How much heat is absorbed? Vacuum means no work is done, no heat is absorbed, right? Obviously we know vacuum. Now 5.3 they said consider the same expansion, means same value, but this time against a constant external pressure. Now this time guys vacuum is not here. In 5.3 they are not talking about vacuum. We have a constant external pressure of 1 atm. So we'll use this formula, Q is equals to minus W. So P external is how much? 1, and final volume is 10, initial volume is 2 liter. So 10 minus 2, 8, right? Now next 5.4 is consider the expansion given in problem 5.2 for 1 mole of an ideal gas conducted reversibly. Again guys they are not talking about the vacuum. They have said 1 mole of an ideal gas. 1 mole of an ideal gas. When ideal gas will come we will use this. Q is equals to again minus W. Why we are taking every time minus W? Because the condition is isothermal. Isothermal means delta U is equals to 0, Q is equals to minus W. Already we know the W value in all conditions. So all the W value is negative. Why? Because work done is by the system. Work done is by the system. All the W value is negative. So here it is Q is equals to minus W. So that is minus and this minus will become plus. Okay. So now ideal gas means guys 2.303 nRT log final minus final by initial to 2.303. N is what? This 1 mole. N I said number of mole. N is 1. R is gas constant. We'll take this only 0.8206. Okay. Temperature if they will mention guys 25 degrees Celsius. So every time we will take the temperature in Kelvin. So 298 Kelvin. Log of final is what? 10. Initial is 2. So 10 by 2. 2 means log 5. So then log 5 value is what? Log 5 value is this. So you will get the answer. Log 5 you will get the value from the log table. Or sometime they will give the value of log. Okay. So I hope you understand till here. In the next class we'll start with a new topic, that is enthalpy. If you understand guys, just hit a like button, and if you have any doubt you can ask in the comment box. So in the next video, before starting that, first I will clarify the doubt, then we'll start the video. So if you'll understand guys each and every concept guys, so that's why I'm teaching you concept wise. No need of by hurting the formula, no need of by hurting the conditions, nothing. Just they will give the wordings. With the help of wordings we will apply the conditions and then we will get the formula, because the conditions we know when what the things they will write. So what will happen? Isothermal means delta U is equals to 0. Why delta U? Because temperature is 0, so heat will become 0, and if heat is 0 means no work expansion is happening, work is also 0. So that's why what you have to do is, in place of by hurting the things, just understand the right concept. If you understand the concept, then what will happen? Whatever the condition they will write, with the help of condition you will write down the what? values, and then you will apply and you will form the formula. So that is the thing, and it will become very easy to solve the problem. Otherwise you have only one thing, that is keep on by hearting, keep on by hearting. So it is not easy to by heart all the formulas, all the conditions, because thermodynamics then equilibrium, it is a very big lengthy chapter. Okay, so that is the thing. Okay guys, thank you, bye bye. This is for this video. We will meet in the next class.